In this video, we are going to do a free throws probability density function, or PDF example. So the example says that Shaq is working on his free throws. He makes 55% of his free throws. He does a practice drill in which he takes 20 free throws. Let X be the absolute value of the difference between the number of makes and the number of misses. Find the probability that X equals 2. Okay, so there were a lot of words in what X represents here, but part of what it says is we're after the probability that X equals 2. So let me put an implication arrow. And then based off of what X is, it says X is the absolute value of something. So let's put a big absolute value. And I know that, well, what goes in the absolute value? It says it's the absolute value of the difference between something and something. So the word difference in math means we are subtracting two things. So what are we subtracting? It says it's the difference between the number of makes and the number of misses. So we're going to be doing the number of makes minus the number of misses. So when it says X, our random variable, which is this whole thing in the absolute value, equals 2. I need to set this whole absolute value to be equal to 2. Okay, so there are two ways if he's taking 20 total free throws for the absolute value of the number of makes minus the number of misses to be equal to 2. But just to get a feel for it, let's just say hypothetically he makes 16 and he misses 4. Remember, they got to add up to 20. That would mean that X is the absolute value. Actually, let's switch those numbers just so it's a little bit more interesting. So 4, he makes 4 and misses 16. 4 minus 16 in absolute value. Oops, let's write that better. 4 minus 16 in absolute value. That would give us X equals absolute value of negative 12. Which is positive 12. So this is just to get a feel for, well, what is X actually computing? So that would make X be equal to 12, but we want X to be equal to 2. And as I was alluding to earlier, there's two ways or two cases that make this happen. So one way it can happen is if the number of makes is 11 and the number of misses is equal to 9, that would make, when I subtract the 2, I would get 2, and then the absolute value of that is still 2. But also if I switch it, if the number of makes is 9 and the number of misses is equal to 11, because even there, after I subtract the two numbers, 9 minus 11, I get negative 2. But when I absolute value that, I will get positive 2, like I need it to be. All right, so we got to work out the probability in each of these cases next. All right, so let's look at case 1 first, where he has 11 makes and 9 misses. So when we have two possible outcomes like this, for each of the trials, either a make or a miss, I can write down the probability that we have a make, and that's 55%. As a decimal, that's 0.55. So the probability of him missing would be 45%, which is 0.45. So this is going to be a Bernoulli situation because we have these two outcomes for each free throw or each trial. So this is P, because we're counting a success as a make here, and the probability of a miss. This I'm going to let be Q. All right, so we are now ready to write down the probability that he has 11 makes and 9 misses. So if we use our formula to compute Bernoulli probabilities, I would first need to find the number of ways to have it's 11 makes. 11 makes, and how many total? free throws, 11 makes in 20 shots. So the number of ways we could have those 11 makes occurring, and then multiply that by the probability of each outcome. Okay, so for the number of ways to have 11 makes in 20 shots, this is going to be a combination because the order in which we place the makes doesn't matter. Okay, so this is going to be 20, choose 11. It's like we're taking 20 shots and we got to choose 11 of those spots to be occupied by makes. And what's the probability of each one going to be? Well, we got to take P, which is 0.55, and raise that to the 11th power, how many successes he had, how many makes he had, and then multiply by Q, which is 0.45, and raise that to the number of misses, which is 9. Okay, and I'm going to leave it like this because eventually we're going to have to add this to what we get from case 2. And I'm going to have to round at the end, but it's computationally it's nicer if I just keep everything as it is and round at the very end. All right, but we are ready for case 2 first. Okay, so with case 2, I want to let you try this one on your own first. So pause the video for 2 minutes. See if you can do case 2 and then wrap it up from here. 4, 3, 2, 1. Pause it. Try case 2 for 2 minutes and see if you can finish this one up. Alrighty, so hopefully you paused it and tried this for about 2 minutes. Let's talk about it together. So in case 2, we need to have 9 makes and 11 misses. So if we were to write down the probability of him having 9 makes and 11 misses, this would be equal to, first I got to find the number of ways to have, now to have 9 makes in 20 shots and 20 of these free throws, and then multiply that by the probability of each outcome. Okay, so for the number of ways to have 9 makes in 20 shots, this is going to be 20 choose 9. I got to choose 9 of those 20 shots to be occupied by a make. Okay, and then I multiply this by this probability. So I need to have P, which is 0.55, being raised to the number of times he has a success, has a make, which is 9. And then I multiply by Q, which is 0.45, being raised to the number of misses, which is 11. All right. So we are ready to write down our answer at this point. So the probability, remember our notation was asking, what's the probability that x equals 2? And we have these 2 disjoint cases here. So we get to add these values up. So we get to do 20 choose 11 times 0.55 to the 11 times 0.45 to the 9 plus 20 choose 9 times 0.55 to the 9 times 0.45 to the 11. And I'm gonna, if I worked this out ahead of time, I rounded it to 3 decimal places. This is approximately equal to 0.296. And like I mentioned earlier, it's helpful in questions like this where I need to round to not round until the end for best accuracy. And the reason for that is each time I round, it's off by a little bit. So there's some rounding error. So if I round a bunch of times and then I put all those answers together, it sort of compounds that rounding error. So if I only do it at the end, I limit that rounding error.